Welcome to today's video. In this episode, we'll explore how assessment literacy and the dual process decision model can transform teaching and evaluation in science education. The video content mainly focuses on the review and reflection based on the above two papers. So, how could the concepts or findings in the article be applied to real-world science education or assessment scenarios? Assessment in science education is not just about testing students' knowledge, but also about supporting their learning. Assessment literacy plays an important role in science teachers' effective implementation of inquiry-based science teaching. For instance, formative assessments like research proposals, concept maps, and mind maps can help students articulate their understanding of scientific principles. Teachers can use these tools to provide immediate feedback, guiding students to refine their hypotheses and improve their experimental designs. An example would be a teacher asking students to create a concept map on photosynthesis. By analyzing students' explanations of key concepts, teachers can identify misconceptions and address them in subsequent lessons. The dual process decision model, combining data-driven methods with intuitive insights. Through data, such as standardized tests, teachers assess knowledge levels, while classroom observations reveal engagement and motivation. In real-world scenarios, a teacher may collect data through quizzes or standardized tests to measure knowledge. At the same time, they rely on intuitive observations, such as noticing a student's enthusiasm during a science experiment. These observations often reveal non-cognitive factors like motivation, which data alone may not capture. The articles provide a comprehensive perspective on improving assessment practices in science education. One of the key insights from the article is the importance of aligning assessments with the goals of inquiry-based science instruction. This means designing tasks that not only test knowledge but also develop critical thinking, collaboration, and scientific inquiry skills. Teachers can integrate self-directed learning tasks, such as asking students to come up with their own scientific investigations. This not only encourages students to learn deeply, but also allows teachers to assess their creativity and problem-solving skills. Based on the concept of dual process decision-making, teachers can use data from standardized assessments to evaluate overall student performance while relying on intuitive observations to identify specific behaviors, such as perseverance demonstrated during an experiment. Because science learning is dynamic and multifaceted, these combined insights can provide a richer understanding of student progress. From the article, I learned the importance of balancing formative and summative assessments. Embed formative assessments into daily teaching through classroom questions, real-time feedback, learning logs, etc. Use assessment data to optimize teaching. Collect data from formative and summative assessments, analyze students' performance patterns, and adjust teaching content and strategies based on assessment results. Create a feedback loop. Provide formative feedback multiple times before summative assessments to help students improve their final performance. In addition, the article also emphasized contextual decision-making in assessment design, through which I learned that teachers should consider the unique needs and characteristics of students when creating assessments. Thank you for watching.